Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at some advanced quadratic equations. So this first equation isn't too difficult because we know for any quadratic equation, whether you're factorizing using completing the square or the quadratic formula, you need to make one side equal to 0. So to do that, we're going to have to expand the brackets here. And then we're going to have to make one side equal 0. So here, I can just do that by getting rid of x squared from both sides. I get negative 12x plus 36 equals 0. You know how to solve that. Subtract 36 from both sides, divide by negative 12, you get x equals 3. All right, that was an easier question. Let's look at some more challenging questions. So each of these three equations here probably doesn't look to you like a quadratic, but we can make them into quadratics. We can do this through substitution. So what we're going to do in the first one, we notice that this term is just this squared. So if I let y equal x squared, y squared is just x squared squared, it's just x to the power of 4. I can rewrite this equation as y squared minus 8y equals 9. Now we know how to solve this. We've done a million times before. We need to make one side equal to 0. And this can be solved easily through factorization. The two numbers that multiply to negative 9 and add to negative 8 are negative 9 and 1. So what we found here is y equals 9 or negative 1. But our question requires us to find the value of x. So we'll substitute back. We said y was x squared, so we've got x squared equals 9 or x squared equals minus 1. Now x squared equals minus 1 has no solution. You can't square and get a negative. Now if x squared equals 9, we simply have x equals positive or negative 3, and we're done. We're going to use a similar trick here because this is the same as that squared. So if I let here y equal root x, this equation becomes y squared, so that y squared is just x, plus y equals 20. We know how to solve that. We subtract 20 from both sides because we've got to have one side equal to 0. And now we can factorize the two numbers that add to 1 and multiply to negative 20. We've got y minus 5 and y minus 4 equals 0. So using the null factor law, we get y equals negative 5 or 4. So because y was root x, that means root x equals negative 5 or root x equals 4. Now when you square root a number, you can't get a negative. It has to be a positive answer. So that gives no solution, but root x equals 4 has a solution. You just square both sides and you get x equals 16. So that one is done. Let's look at this one here. Again, it probably doesn't look like a quadratic, but we can easily make it into one. In this case, we don't need a substitution. All we're going to do is multiply both sides by x. That will get rid of this fraction here. So multiplying everything by x, I get x times x is x squared minus 30 over x. Well, when you times it by x, you just get rid of the denominator, and then I get equals 2x. So making one side equals 0, I get x squared minus 2x minus 30 equals 0. So this quadratic cannot be factorized easily, so let's use the quadratic formula. We'll start by calculating the discriminant. So the discriminant is b squared minus 4 times a times c, which is 124. So using the quadratic formula, x will be minus b plus or minus the square root of the discriminant, all divided by 2. So we can simplify root 124. It's just root 31 times root 4, or 2 root 31. So this is 2 plus or minus 2 root 31 on 2. So I can just divide everything by 2. It'll be 1 plus or minus the square root of 31, and we are done. All right, let's now look at one that involves simultaneous equations. So here we need to calculate the values of A and R if these two equations are true. So straight away, when you have two equations and two unknowns, you should be thinking simultaneous equations. So because A over 1 minus R equals 100, we can easily rewrite that as A equals 100 outside of 1 minus R. So using what we know from simultaneous equations, we could just substitute that here. What we're doing, whether we use substitution or elimination, is we're trying to reduce this to one equation with one variable. So I can do that here. I'm just going to take this equation and replace A with 100 outside of 1 minus R. So that gives me A, which is 100 outside of 1 minus R, times R equals 24. And this is where the quadratic comes in. We now have a quadratic equation. 100 times 1 times R gives 100R. 100 times negative R times R gives negative 100R squared. So we want to make one side equal to 0. We do that whether we're using completing the square, quadratic formula, or factorization. Always we need one side equal to 0. So I'm going to add 100R squared to both sides. I'm going to subtract 100R without the squared, and then I've still got my 24 here. So because of the numbers, they're a bit big and complicated, let's use the quadratic formula again. So I'm going to calculate the discriminant. So the discriminant is B squared minus 4 times A times C. Now, if you put that in your calculator, you get 400. So that means here that R is going to be minus B plus or minus the square root of the discriminant. The square root of 400 is just 20 all over 2 times A. So 100 plus 20 over 200 is 0.6. 100 minus 20 over 200 is 0.4. So we're not done here. We found R, but we need to find A. Well, A is just 100 times 1 minus R. So if R equals 0.6, A is just 100 times 0.4, which is 40. And if R is 0.4, A is just 100 times 1 minus 0.4, 100 times 0.6, which is 60. All right, we are done. Thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.